Today I'm going to be speaking to you about the importance of annulus in resin bolting. Our presentation will cover 4 topics. Firstly, what is annulus? Secondly, we'll look at traditional bolting shortcomings. Thirdly, we're going to look at a couple of examples of gloving. And lastly, we're going to try and answer the question as to how we will address the annulus problem. What is annulus? Annulus is the relationship between the hole and bolt diameter. For resin bolting, an ideal annulus is between 4 and 10 millimeters. Traditional bolting shortcomings. When the annulus is above 10 millimeter or below 4 millimeter, stiffness and load transfer capabilities reduce significantly when using standard resin. During rock movement, the load is transferred from the bolt to the rock via the grout by the mechanical interlocking action between surface irregularities at the interfaces. When axial shearing occurs during rock movement, the load is transferred to the bolt as the grout interface shears. The ability to transfer load between bolt, grout, and rock depends on grout annulus, grout strength, bolt profile characteristics, the roughness and strength of the rock, and the mechanical properties of the bolts. Slippage may occur at the rock, grout, or grout bolt interfaces, both being called decoupling. Decoupling takes place when the shear stress exceeds the strength of the interface. Mixing. For a system to work properly, resin and catalyst needs to be mixed to a homogeneous grout. Mixing is compromised with annuli above 10 millimeters and finger gloving may occur. The danger is that the installation may look fine but could underperform in relation to the design requirements. Finger gloving occurs when either or both the catalyst or resin compartment of a resin capsule have not been pierced by the roof bolt on installation. When this happens, the catalyst and the resin mastic cannot be mixed, no chemical reaction will take place, and the resin will not set. Below are examples of finger gloving. If one looks at the example on the left, one can clearly see the resin mastic is still wet. No catalyst has been mixed with this resin mastic, and setting of the resin has not occurred. Annulus is not a problem in a coal mine where smaller holes are easily drilled, or in hard rock mines where mechanical roof bolters are used. Where bolts are installed with conventional equipment, installations could be difficult when trying to maintain the recommended annulus parameters. How do we address this problem? We can drill smaller holes. 28 millimeter holes have now for a number of years been successfully drilled in hard rock mines. The only drawback of this is that the operator will possibly need 2 sets of bits. 28 millimeter bits for the support holes, 34 millimeter bits for the blast holes. If proper controls are not in place, this could become a safety issue, whereby the operator uses the 34 millimeter bit to drill the support holes, whose design has been done around a 28 millimeter drill bit. We can use larger diameter bolts. The weight of these bolts would make them difficult to handle, and also steel is very expensive. We could use annulus correction bolts. We could use bolts with additional mixing elements or deformities. These, however, can be difficult to install if the mixing elements and the deformities are too large and the air pressure using handheld installations is too low. If the holes are too large and the resin capsule diameter not large enough, there might be a problem in filling the hole with resin and the bottom portion of the hole is not grouted. Do we only get a point anchor when using these bolts in larger diameter holes? Do we get proper mixing and anchoring along the entire length of the bolt? We use short encapsulation pull tests to evaluate resin bolt performance. These short encapsulation pull tests only evaluate the resin bolt performance at the top of the bolts. If one is using, say, a 1.8 meter bolt, it would be impossible to evaluate the in situ resin bolt performance along the entire length of this bolt underground. Should we not be doing more work on this in a laboratory, where we look at mixing along the entire length of, say, a 1.8 meter bolt and do short encapsulation pull test at the top, middle and bottom portion of this bolt? I'd like to thank you for your time. Are there any questions?